2023, Chapter 9, Section 2, Linear Regression. Alright, first of all, linear regression means that we're trying to find an equation, a linear equation, that will allow us to predict values within the other values. We're not going to interpolate we're not going to extrapolate, so we're not going to do anything outside the points, but we would like to be able to predict something inside the points. Also, make sure you understand that the regression line, which we're going to calculate the equation for, is also called the best fit line. The reason it has to be called the best fit line is because, unlike algebra, the points don't fall into a perfect straight line. The points fall all over the place. So what the best fit line is the line that can be drawn that gives the shortest perpendicular distance between each point. So if you look at this line here, if we shift it up, we increase the distance here, but decrease the distance here. If we shift it down, the opposite happens. So what happens here is this is the line that has the shortest perpendicular distance between this point, this point, this point, this point. If we adjust it in any way, we take away the shortest distance from all points. Does that make sense? Shifting it up, we shorten the distance here, but we increase the distance here. Shifting it down, we decrease the distance here, but increase it here. The way it is now, it's the shortest distance for all the points, perpendicular distance for all the points. So, here's what happens. Linear regression means best fit line. It comes along the same concept as slope-intercept form in algebra, where y equals mx plus b. And m is your slope, b is your y-intercept. In linear regression, you're going to see it written as y hat, which means predicted y value, equals ax plus b. All they do in statistics is they're replacing the m with an a. It's still a slope, and that's what I've indicated here. A equals slope, which equals m in algebra. B equals b, which is y-intercept. So we come over here, we start with our example 1, and we have this list of data here. We have our x values, which is the GDP. We have our y values, which is the carbon monoxide poisoning. And so the first thing we're going to do here is we're going to go to stats, we're going to go to edit, and we're going to list all the x values, which is the GDP in list 1, all the carbon dioxide emissions values in list 2, which is the y's. Again, remember, when you're putting information in a list, you have to second mode, which is second quick the list. You got to get out of that list. Next thing we're going to do is we're going to hit stats. Now, we're used to going to tests. Well, now we're not going to tests. We're going to calculate, because what we would do is like to calculate the linear regression equation. So what I'm going to do is I'm going to hit my right arrow to calculate. You can see right here where it says linear regression ax plus b. So we're going to move down to number 4. And I'm going to hit enter. Now notice all the calculator is doing is asking you, where are your x values, which are in list 1 for this particular problem? Where are your y values, which are in list 2 for this particular problem? Now, frequency list, don't mess with. The one thing you will have to do, though, is if we move down to store equation, and what that's asking you is, okay, once the calculator figures out the equation, where do you want to store it? And what we want to do is we want to store it into the y1 or the y equals. And this is how this happens. We're going to hit vars. And notice the menu we get there. We get vars and then we get y vars. Press your right arrow, go over to y vars. Notice that the cursor's at function. We want to keep it at function. And then we want y1 because we want to put our equation in y1. So what I've done there is I've gone through vars, y vars, function, enter, and I've told the calculator when you calculate the equation, put it in y1. So now all we do is we move down and we hit calculate. So it gave me my A value, which I can put in place of A in the equation. It gave me my B value, which I can put in there. So it's really giving me the equation y hat equals 199.5x plus 56.04. Also remember that if we want the mean or average for y, all we got to do is take the sum of the y values, divide by the sample size. If we want the mean or average for the x's, we take the sum of the x values and divide by n. Now we have an equation at which if we wanted to calculate a particular value of the CO2 emissions for a particular value of GDP, we got this right here. Also, make sure you understand that, unlike in algebra where we just deal with variables y and x, in statistics we have to know what y and x equals. So in this particular example, y hat, which is the predicted y values, is always going to be the CO2 emissions. X is always going to be the GDP. So we can calculate either one by putting a value for the other one in. Now let's go back to the calculator. Notice that when I calculated a regression, it gave me r squared and r. We just talked about r in the last section, which is telling us correlation. So we can see that this has a pretty strong positive correlation because it's 0.87. Remember, r is only going to be between -1 and 1. We see that we have r squared. R squared is what we call the coefficient of determination. What the coefficient of determination is it explains, is the ratio of explained variation to the total variation that it is. So what it does is it really tells us how much of the x variable, how much of the y is being explained by the x. The value for r squared is going to be somewhere between 0 and 1. 1 meaning 100%. So the higher your r squared value is, the better off you are. In this particular example, we can see that our r squared value is 0.76, which means 76% of the variation in CO2 emissions are explained when GDP is used with this equation. So it's a 3 out of 4 chance. So that's what r squared is, coefficient of determination. One last thing we have to look at, this is example 3. You've done this in algebra. It says the regression equation for the gross domestic product and carbon dioxide emissions data is, which we just calculated. It says use this equation to predict the expected carbon dioxide emissions for each gross domestic product. They give us number 1 is 1.2 trillion, 2 is 2 trillion, 3 is 2.6 trillion. All we're doing is because that's the gross domestic product, we're going to stick it in for x. So here's where we stick 1.2 in there, and we can expect 295.478 million metric tons of CO2 emission. Plug 2 in there, we get 455.106, 2.6 in for 574.827. So remember, on these equations, you have to be able to not only calculate the equation based on y hat equals ax plus b, but also you've got to know what y is and what x is, because I'm going to ask questions regarding what the variables represent.